Hello everyone, here we want to study about the Gaussian process. So if we see, Gaussian process is the important family of random process. These are useful in the communication system because thermal noise produced by system devices can be modeled as a Gaussian process. So we can define Gaussian process as a thermal noise which is produced by the system devices. So here, if we are taking one example, like if we are talking about the electrons movement. So each electron's movement in a device is random in nature and it will act as a source of current independently. So we can calculate here total current, that is the sum of large number of random variable. So according to the central limit theorem, this sum will be taken as a Gaussian distributed. And here we will see some more properties of the Gaussian process which will help in analyzing a system with ease. So if we are considering a random process, at that time you can see here, if we are taking y as a linear function of x of t. X of t is nothing but the random process. So we can take the process x of t as Gaussian process. When if every linear function of x of t is a random Gaussian variable. So if we are taking the y as a linear function of x of t, you can write y equal to integration 0 to capital T g of t x of t dt, where we are considering g of t as a sum functions. So we can take like Gaussian process as a x of t, but it will be the Gaussian process if every linear functional of x of t is a Gaussian random variable. So we can write here as, you can take f or you can take p, f y equal to 1 upon square root of 2 pi. You can write in square root sigma y square, or you can write square root of 2 pi into sigma y into e to the power minus y minus mu y square upon 2 sigma y square. So here we can say the random process is a Gaussian process if for all time variable and for all n the random variable x of t I have jointly Gaussian density functions. So we can say at any instant to the random variable x of t0 is a Gaussian. If we are taking at any 2 point t1 and t2, at that time you can take the random variable x of t1, x of t2. These are distributed according to the two-dimensional Gaussian variable. So we can say that the random variable has a Gaussian distribution if it is having the probability density function which is having the form like fyy equal to 1 upon square root of 2y sigma y e to the power minus y mu y square upon 2 sigma y square. So if we are taking its normalized form, you can take that as fyy equal to 1 upon square root of 2 pi e to the power minus y square upon 2. So here we can take the normalized Gaussian distributions of the random process. You can observe the waveform. So here now we can see the some properties for the Gaussian process. For that we are supposed to see about the central limit theorem. So if we are considering let x comma I 1 2 3 up to n be a statistically independent RV, and it will have Ix and various sigma x square. Since they are independently and identically distributed, we can take the normalized xi, that will be as yi equal to 1 upon sigma x, xi minus mu x, where I equal to 1 comma 2 up to n. Hence we can take e of yi equal to 0 and variance yi equal to 1. So we can take v of n, that will become as 1 upon square root of n, summation I equal to 1 up to n yi. So we can say that as a central limit theorem. So here we can say the probability distribution of Vn will approaches n 0, 1 as n approaches infinity. So now we can see some important properties of the Gaussian process, because some important properties of the Gaussian process which make analysis of the communication system easier. These are necessary to the study. So here firstly we will see the first property of the Gaussian process, that is, if we are taking Gaussian process at that time, if we are applying it to a stable linear filter, then random process will develop at the output of filter will also as a Gaussian. As you can see the diagram 1. So here we are saying if a Gaussian random process x of t is applied to a stable linear filter, then random process y of t developed at the output of filter will also work as a Gaussian process. So we can prove this. How? If we are considering the y of t, that will be equal to, we are supposed to take here that output in the form of impulse response. So here we are giving the Gaussian process as input to the stable linear filter. So we can take here output that will be as a response of a filter. So you will get y of t that will be equal to integration 0 to t h of t minus tau into x of tau dt, d tau. So here we are saying we are taking h of tau, that is nothing but it is the response of filter. So we can take y of t, that is can be written in the form of summation. We can write in the form of summation also. How we can write? We can write limit n tends to infinity, limit delta tends to infinity, integration j equal to minus n to n, x of j delta h of t I minus j delta. So we can say here as x of j delta is a Gaussian vector and y of t becomes a linear combination of these vectors. So we can conclude that we will get the y of t, that is nothing but a jointly Gaussian. So here we can define if we are taking z equal to, like you can see here.